Everybody to episode 105 of the No Normal Show for Thursday, May 27th, brought to you by Revive Health. This is our weekly deep dive into how hospital and health system marketers can navigate what we call the no normal. I'm Chris Bevelow, health systems practice lead at Revive Health, and your host for the show. I'm joined by Chase Kleckner, who is senior marketing manager and master prankster at Revive Health. He's also the show's producer. Hello, Chase.
Hey, Chris. Good to see you as always.
Yes. We're in a whole new world here. So thankfully, our guest today wears two hats. Chris Hemphill. Chris is on one hat is the vice president of client AI and growth for SymphonyRM, which focuses on using data science and machine learning to aid strategic projects for health systems across the country. He has a 10-plus year career focusing on data analytics in the healthcare space, and since joining SymphonyRM in 2019, has used data sets with thousands of physician liaisons, millions of patient interactions to help value and direct physician engagement efforts. His second hat is he knows how to do a live LinkedIn show, which is a first for us. So thank goodness you're here. Welcome.
Thank you for having me. It's exciting to be a part of this groundbreaking LinkedIn experience.
Well, let's hope it's not groundbreaking in the way that, like, when you first launch a new model of rocket and it goes about 4 feet off the ground and then explodes. That's what I'm hoping doesn't happen, but I'm sure it'll just be fine. We're in good hands with Chase, and Chris is our backup. So we've got a lot to talk about with Chris. We're going to get that in a second. Just some show notes. If you're new to us, whether you're new to us here on LinkedIn or whether you have not heard the No Normal Show before, this podcast is where we share industry trends, research, stories. We bring in people from outside healthcare, from within, all of it to help health system marketers navigate what we call the no normal successfully. Not the new normal, not the new normal, the no normal. If you don't want to know what we mean by that, Chase will post a link to a blog post we wrote that explains what we mean by the no normal and why it's still relevant even today, and likely will be at least through the rest of this year, if not beyond that. You can find that in the comment function of our show here. And if you are live with us and you want to join in the conversation, use that comment section. We'll keep an eye on it. If you have questions for Chris or myself or Chase, we may also call you out if you share a pithy or smart comment there. So just throw it in that comment section. Also, Chase will continue to provide any relevant links in that section. And remember, you can always subscribe to the show as a podcast on iTunes, Spotify, or wherever you listen to podcasts. We will typically have that up and ready to go by the next day. That is tomorrow by 11 o'clock Central Time. And if you want a back catalog of all of our 104, I guess by then it'll be 105 episodes, you can find those at our website at thinkrevivehealth.com/no-normal. And you will find all of them, as well as some hints about who's coming up next. All right. So I think I covered it there. We're still live. We're still okay. Still moving up into the atmosphere. This is all good. Let's talk about AI. So thankful to have Chris here to talk about AI in healthcare specifically. This is really important to me personally because I'm working on a project that I can't really share what it is, but you all know about it pretty soon, where we're going to be talking a little bit about the influence of AI in healthcare. And I admittedly am not an expert in this space until very recently, couldn't really even articulate the power of artificial intelligence. Even some of the definitions throw me. Actually, thanks to Chris's company, they have a phenomenal resource online. I encourage everybody who wants to know more about AI or even just to get started in it, to get grounded in it. They've got a series of videos that is just really well done to help people like me and others get their arms around this. So we're going to be diving into that today, and we'll see how deep we can get without getting ourselves in trouble. So Chris, start just with artificial intelligence. Like, give us the 101 on it. We'll just start there.
Great. So the 101 on artificial intelligence, I could go for a long time, but your overall perspective is what's the best way to get a system, get a computer to make a decision or choice outside of human intervention. And the value in that overall is that, hey, if we can automate decision processes, or if we can use the power of AI or algorithms or what have you to do analysis on a level that like we couldn't manually do, then we can start making better decisions overall for overall strategic objectives. That's called your decision intelligence domain. Or if you're trying to automate decisions across populations, such as a very common use within healthcare is to identify who might be at risk for what illness or who has a likelihood to do something. That's often there's a domain called propensity modeling that's pretty close to that. But overall, the concept, especially the most recent the most recent way that it's being used is to identify, like using data, using systems, identify what traits, what characteristics are going to be most likely to have some result happen.
Okay, so where rubes like me get stuck is, okay, so you mentioned so we don't have to do it manually. Of course, you didn't mean literally manually. You didn't mean like creating Excel spreadsheets, though I'm sure that is a process some people still use. We've been using, computer technology and computer capabilities for a while to crunch numbers. Talk to us about the difference, if you can, between how we've approached things like that in the past and what AI does differently and the power of it or the benefit of it. So we can kind of get the difference between, well, we've been doing this for a while, but here's how it's going to be different going forward.
Great way to sum it up. And let's go to that Excel example, because like if I have a list of people, and let's say that I have their height, weight, and then a bunch of other characteristics about them. The more columns, the more information that I have, and a column is kind of like a characteristic or a variable, or a lot of people in AI will call those features. The more features that I have, the more complicated it gets. Just think about like looking at a spreadsheet. The more complicated it gets to start being able to figure out, well, what's related, like, is this column related to this column? What's the difference if I adjust a value in height? What's the difference in the outcome I'm trying to measure? So imagine that my head starts spinning after about 4 or 5 columns. It starts no longer making sense to me. So imagine if you're having entire patient populations, hundreds of thousands or millions of interactions that you're tracking. And these are individual events where somebody's come in, they've had an episode of care, there's been diagnosis, there's been procedures, there's been biomarkers tracked at each of those. So that results in hundreds and hundreds of these various columns, or as I said, features that are describing that person's interaction and history. So the concept here is to, like, I'm just trying to expand from that concept of what you would do with the spreadsheet, and ultimately say that what a machine learning approach is doing is looking at all those features and characteristics, and looking at the variable of interest, the target that you're trying to identify. To keep it really simple, let's say that our target is people who might need cardiovascular services. Just broad. We'll keep it broad at that perspective. But the idea is that if I have enough examples of people who have needed cardiovascular services, then by taking a machine learning and data science approach, I can start identifying characteristics that would predict additional people who might possibly need those services. So the basic idea here is we're looking at complex data sets, and we're using the information that we've collected within that data to predict like future instance or future need, or people who might need these services and not know it. So the basic concept is if we're going to boil it all down to what we're trying to do, tell me what I don't know about my population, tell my patients what they don't know that they need to know, help them to be able to intervene early, so that we can have a data-driven way to direct our communications appropriately, deliver people deliver people to the services where they're going to get the experience that they need.
So I'm going to see if I can repeat that back to you to see if I've learned anything. And if you will, I would like to use the example that you guys use in your Health AI University, because I think it's like, again, for people that are trying to grasp all of this, you really broke it down to kind of 3 different parts of a process. And in the old way, you would have all of your data. So let's say it's information about just a patient set or a bunch of people, right? And let's say our goal is to try to identify cardiology patients, right? So the old way, you'd have all of this data, and you would start assigning rules for the computer power to use. So you're going to say, all right, look for people that are a certain age, look for people that have had high blood pressure, whatever. And you're gonna tell the computer which of those columns in the Microsoft Excel chart are important. And the computer is going to say, okay, you have told me to do this, so I'm going to find the best examples, and that's going to end up in these results, which is great, but it's a very set approach. You've told the computer what to do, and that's what the computer is going to do. And there's limits to it, because you as a human aren't going to get all the different variables that actually could matter. And so you're always going to be limited, right?
Yeah. And I want to just make that personal. Just specifically, I was looking at the age range that got put out by a cardiology model. And what I like there's often, like, if we're going for cardiology patients, like in the old world, people might say, well, we want to reach people that are 55 years or older, male, this particular occupation, or what have you, in a lot of cases. But what we were seeing from the models, that they were like, let's say that you went with the old world approach and said 55 and above. We're gonna target people that are age 55 and above. There were several thousand people that were flagged as high risk by this approach, that would have been excluded from kind of that old way of thinking. So if the concept behind AI is to use those different characteristics and really deep nuances between how those different characteristics, age, systolic blood pressure, various biomarkers, how get into really deep differences and nuances in how they relate to each other. Because what if 55 is a good split? Unless somebody is 45 and has come in for these encounters in the past, or has other biomarkers that are related, it gets really hard as a person to start building out a more and more complex tree with all those nuances. So machine learning, the concept is to be able to find those nuances and not exclude those people who need the.
We're going to get to machine learning in a second. Hold on to that, right? So again, 3 simple things. You've got your data that you're exploring, you've got rules that you've assigned to the data, and you get your answers, right? But with the downsides that we just talked about, you pointed out that, like, hey, those answers are predicated on the rules you dictated, which isn't going to be the most accurate output. The way you guys describe it is you've just really swapped 2 of those things in the equation. So imagine that you still have this data that you're exploring, but instead of setting rules, you say, this is the answer. So you take what before was the output and you make that part of the input. Say, this is the answer. This is what a cardiology patient is, right? You don't try to define it. You say, this is what it is. And the computer, with its processing power, figures out, okay, these are the rules, what you guys call a model, that then helps us decide what those look like in the future. So you can take that model, which is going to be far more accurate, because it's based on the computer figuring out from the data and the examples you've given, this is what it looks like. These are the characteristics, instead of the reverse, where you're trying to tell it the characteristics. That model that is the output now, which was the input, the rules, now the output, you can then apply to other data sets. And that's going to be far more accurate, and continual learning with the AI. So just a simple way to look at it. You guys did such a great job of that. Now, you said machine learning, AI, machine learning, natural language processing, they're all related. Help people figure out how they're related, just real quick.
Sure thing. So, I dropped the ML word, and the like when we're talking about AI, if you really want to get broad with it, like there's so many subspecialties and subfields of AI, including a field called symbolic AI, which is where somebody, you can call it symbolic AI or the term expert systems, because it's still valuable and still very much in use and producing results today. But that is the approach where somebody is using their domain expertise and their understanding of a problem to identify, hey, these are the features and the relationships. Of course, we've kind of outlined where that expert systems perspective can break down. But the machine learning approach is very akin to the data-driven approach that you outlined. There are some nuances there when it comes to like your common machine learning methods. There's supervised learning, unsupervised reinforcement learning. But to keep it simple, I'll focus on just that supervised learning domain, where it's really what you've outlined. We know what an outcome is in a historical data set. You said it. You said, hey, these are the answers. Like historically, these are the people that have come in for the cardiovascular service, and these are the people that haven't. So to a degree, we know the answers. We can get really nuanced about if you can truly know that from EMR data. But ultimately, what the machine learning assumption is that, hey, we know the answers, and here is figure out a way to match the people in this population who fit those answers, and then see if we can use that to predict new cases, new people outside of that original population that we tested on. Yeah.
And again, if you're not versed in this, it can get really confusing. It doesn't have to be. So it helps to have someone like Chris explain all this. And again, I'm just going to throw it back to your the video series you guys did. Use an example of use cardiology patients, but first you start with trying to identify what a ball is. And it's just such a clear example of how all this works. It's just brilliant. So again, a shout out for that. So let's bring it back to healthcare. Where are we at today in healthcare? You know, I joked with somebody, this was a couple years ago, and I was speaking following the last book I wrote, and somebody said, is your next book going to be on AI? And part of this was my admitted ignorance in the field. This is 2 years ago. But part of it also was what I knew from AI was IBM Watson Health, which was kind of a big flush of the toilet. And I had learned about AI being used to write sports recaps for like AP or other national news services. And the way I found about it was I came across a couple and I'm like, what is this? Like, this is, whoever wrote this is really weird. Like, they're not from here because they're not using the right vernacular, or they talk about it in a very formal way. And then I'm like, oh, no, some machine wrote this. That explains it all. So I was kind of like, yeah, I'm sure I'm not going to be writing about AI. I don't know if it was far advanced then, but things are happening now. Talk about what's happening now with AI.
So state of healthcare, I mean, well, state of the union with AI, lots of exciting things, especially like when it comes to how sports recaps might be written, or like conversational AI and some of those things that you might be thinking about. If you had looked at the level of content 3 years ago versus now, it's pretty significantly transformed. There was a one way you can actually play around with this. Is there's a conversational model that came out about 2 years ago in 2019 called GPT-2. And there's a website. If you Google "talk with transformer," it actually lets you put in a text, and then what the AI does that you've accessed, it completes the story. Like it puts in some additional sentences from that text. Granted, those sentences, like you're putting in Superman flew around town, and then it's finishing the story with what it thinks that what it's predicting would be the next likely things that you would put in. And I mean, it's up to the level of like dime store fiction. You know, it's like it's not that it's cohesive. It makes sense, but like it doesn't really capture the story. So there's like I was just thinking about that conversation, that content generation piece that you brought up. They're constantly iterating on these models and these approaches to where it was fun to play around with that in 2019, and it'll be interesting to see where those conversational type pieces can go in the future. There's all kinds of different things that you can do with it, that they're doing with like text data right now, such as style transfer. And I wouldn't trust an AI to completely write an article for me just from scratch. Like I feed it some information, it writes a great article. But if I've written it in one style, like if I've written it in kind of a college masterclass style, and I want it to go to a more accessible style, there are algorithms that are focused on doing that. So interesting state of the union stuff. I mean, there's how much of that is hitting healthcare in the next couple of years. I'm not sure, but it's interesting to see kind of like what's happening at the cutting edge there, and how the big fear that people have around AI coming in and taking jobs from like there are domains such as translation, where I'm kind of like I have a friend who is a Portuguese to English translator, and a lot of those shops are trying to use more and more machine learning and pay those translators less. But within the healthcare domain and within like the original content domain, it's not something that I'm seeing being a big job. Like there's not going to be an AI poet or that's replacing our songwriters anytime soon, I think.
Well, there's a comment in the chat from Melissa asking for more specific examples, and there's a number of them. I want to ask you about chatbots, because that's something that we hear a lot about, and we could have Brian Gresh on from Loyal. I'm sure he would love to talk about that too. But I just recently read some things. As an example, Mount Sinai used AI-driven technology to help diagnose lung scans in potential COVID patients. And what they found was a marked improvement in diagnosing COVID when compared to the radiologists. And AI has made quite a stir in the radiology field because they are applying AI to reading scans of all kinds. And it has called into question, like, oh my gosh, is there a future for radiologists? Are we going to need radiologists? And that's pretty extreme. But it's an example of where it's impacting health. I don't know what examples you may have, Chris, but I would love for you to talk a little bit about the chat bot, because that's where I hear it the most in our field in terms of marketing and all of that kind of stuff. Talk about the chat bot and how that's related to AI.
Well, see, the chat bot is kind of like, it's an application. I'm going on and I'm communicating, I'm having a back and forth, and there's some piece of information I want to know. Where AI has a kind of a relevant role there, like where these machine learning approaches might have a relevant role, is figuring out what it is that like what my intent is, what I'm actually trying to question by what I'm saying. So the typical chatbot experience is talking like going back and forth, and perhaps some intent is like some intent is identified, and then they kind of triage you and point you in the appropriate direction. So that's about as far as it is right now. Where I'd see some potential advancements, like we haven't done anything in the area of chatbots, but I feel that if there's some sort of identification that like once you've authenticated onto a website, and there's some additional background on what the health system knows, like let's say that you're identified by the chatbot, and there's maybe some next best actions that are associated with you. For let's just go back to the cardiology example. The experience can kind of start transforming to where if it makes sense to have some sort of communication about things that you might just want to consider for your personal health, then the chatbot can start offering more of a value add to you, knowing that if there's an interest in certain things, or if there's a need for services around certain conditions, it can start subtly communicating about those things with you to enhance the experience. What that would require is like on like on a company like SymphonyRM on our side, that would require some sort of communication with whoever's delivering the chatbot to say, hey, these are the next, like we've identified that these are the next best actions that are most pertinent to this person's care. And once that connection is made online, then there would be sequences or flows that are identified like AI. We're not to a point where it's going to take the human element out of the picture. It's on us to decide what kind of conversation, what kind of sequence, what do we want to engage people with now that we know that they're on our website talking to us and they have risk factors that they might not have previously known.
Yeah, that's a great explanation. And, you know, that again, you kind of think about, well, to your point, chatbot's just really a simple application. But it's also a great way, again, to illustrate the power of AI. Imagine trying to write a set of rules for a computer to step in a chat function to understand all the different possibilities that could come from human interaction around healthcare. It's almost infinite. There's almost an infinite number of things that could happen and paths that could be taken when you think about healthcare. It's different than if you're a stapler company and somebody's using your chat to buy staplers, right? That's a limited set. Still a lot of rules you'd have to write. The difference for AI to pick up on that and learn on its own and continue to build that is obvious when you think about it that way. And really the only way that you could automate a chat function with any real meaning. Otherwise, you get the experience I seem to get whenever I shop and I use the chat. And if it's not a human, I know it within like 30 seconds. And it's like, how can I help you? I'm looking for this. Oh, would you like to speak to a person? I'm like, yes, but give me somebody who can help me. Because we're just in the initial stages of this stuff. It's coming, right? Do you have any other examples, Chris, you want to share?
Overall, so I think the chatbot example is a good one because it highlights another need that we have. I highlighted that there's like in a healthcare perspective, you'd have some separate set of algorithms or even some separate company that's identifying what these risk factors are, what a particular person's needs are. That company, in order to do that, they had to connect with data from EMRs, from claims, from other sources. So there's a big amount of data fusion going into just making that happen. And then there's another fusion layer that would have to happen between the algorithm that's identifying risk versus the one that's like identifying the intent of somebody logging onto the chat. So what I'm really trying to highlight here is that systems need to be able to communicate with each other. We're specialized on focusing on patient engagement and next best actions and things like that. Loyal is specialized on the chat utility and enabling that type of experience. So overall, for healthcare to progress, these organizations that are focused on, a startup is like 60 to 150 people that are focused on something, rather than a bunch of companies trying to become the epic, trying to boil the whole ocean and cover everything. They're for this system to be able to work, systems are going to need to be able to communicate with each other effectively, and that takes us into kind of another domain. Like APIs, application program interfaces. Those are how systems talk with each other and control each other and different things like that. But where I kind of see things going, there's really cool algorithms that are kind of happening on the fringes, but to make this stuff work and actionable for our patients and our communities, it's going to take systems better exchanging data between each other.
So you hit on something in the middle of all that I think is important to kind of pull out a little bit and just have you give a little more background on it, because I think it's really important. So again, pulling back to your the videos you guys provided, and you share about what you're looking for in models. So let's again go back to what we're all here for, which is healthcare. The examples that you guys use in terms of cardiology patients. The power of AI is not just helping us develop clinical models, so clinical propensity. You also talk about engagement models, and you said it when you said we're also looking for the intent of the action. So it's not just, does this person again, to go back to like, is this a ball or an orange? It's a ball, but is it a ball of midair? Is it a ball that's rolling? Is it a ball that's bouncing? There's a whole nother dimension of this that's really important to understand. It's not just, is this person show up in the model with propensity for whatever, heart surgery, but where are they in that process? What is their level of engagement or intent or interest or whatever? That relevance is just as important as understanding kind of the picture of who they are. Am I describing that in the right way?
Completely the right way. And yeah, there's a ton of companies out there that will offer up a prediction on what somebody's what a healthcare need might be. But for AI to fit into that engagement picture, there needs to be an understanding beyond just clinical risk and understanding on what kind of communications we want to engage people in based on what we know about them or based on what we've learned about their intent or what channels they're most likely to use and how what we're operationally able to handle. There's all kinds of different factors outside of just a clinical risk prediction. And I think that like the conversations that you see, the publications that you see, like you referenced a study that used imaging data to identify COVID likelihood, and there's a paper that Google AI put out last year regarding using imaging data for breast cancer. There's a whole lot of stuff out there about about clinical risk identification. But I think that for us on the call and for people that are looking for things that are actionable today, it needs to take into account that engagement picture, and there needs to be a better perspective on just the idea of where it fits in. Like, we're not looking to replace radiologists. There's not some of the past some corrections on some studies that have come out in the past on like using that radiology data have found that like it was extremely accurate on the data that they had, but when you started feeding it new images that were outside of that data set, the accuracy plummeted. So for really intense clinically involved decisions, I don't think that we're there yet. But for when it comes to things like getting communications out to the right people, making sure we're not excluding large numbers of people who might have a particular need for a conversation set, I think we're pretty safe there. I think that's a good way to identify some like winning strategies.
Yeah, I mean, imagine if we had something for the reluctant COVID vaccine folks, and again, in the old way, you'd be like, okay, here are the people that are reluctant to take vaccines. What do we know about them? Well, we know they have this political affiliation or this age, or so let's plug all that in a computer and create like a match and see who else is like that, as opposed to just feeding, here are all the people that are reluctant to take vaccines into an AI modeling, approach. And it determines, all right, this is what we're finding is causing it. Now, this is how we're going to be able to help the next batch of people. Like, it sounds like a subtle difference, but it's really a significant difference, those two different approaches. So where's all this headed? Is it headed to Elon Musk has some things to say about where this is headed. I don't know if we want to go there. I think he said, what's his name? Ray, who's the father of AI? Ray Karowski or something. I'm getting it completely wrong. Yes. He said 2045 is the, what's the famous word? It's the moment of singularity where machines will take over. Elon Musk has said that's actually 2025. So within 5 years, we will be, I don't know what that vision is. If we're behind AI, if machines take over, if it's Terminator 6, I don't know what it means, but where is all this headed for real? Like,
gosh,
not there, I assume.
The only way that I'll even try to give a definitive answer is if you promise to next time you ask that question, you have to bring my name up next to Elon Musk. You have to say, well, Chris Hemphill said it was 4 years out. So
I will do that. I'll put you in there with Ray and Elon and Chris.
But in all seriousness, no, though, that's just something that's extremely hard to predict. And the way that like, if you look at what Elon Musk was saying about the state of the self-driving car 5 years ago, it's not quite there yet. We don't have fully autonomous vehicles. When it comes to that singularity conversation, there was a joke. There have been other people in the past who predicted the singularity too, but it's always 30 years out. So no matter what, it's one of those things that just keeps getting pushed on out. Like 10 years from now, it'll be 2055 maybe. But it's really like predicting outside of like, I mean, there's really cool stuff that's been happening recently, but knowing like when we can expect a machine takeover, I'm not the one to answer that.
That's okay. Just tell us where it's going in the next few years in healthcare. Like, we'll keep it out of the Elon Musk dystopian bucket and just in the practical advancement of AI in healthcare. What are some things you're looking at?
So some big things. I think that over the past few years, there's been a lot of interest in like these algorithms that take in huge data sets and then make predictions. But what's more interesting right now is being able to identify causes. This is a little bit on the fringes, a little bit forward, but like if we're able to make predictions, we've developed algorithms that tell why the algorithm was making those predictions, but that's still not getting down to any kind of a true causal discovery. So kind of a budding area in data science right now, and like causal modeling and that's existed for decades, but now we're getting to a point where there are approaches and there are large enough data sets and large processing power to where people can start exploring causal discovery within these data sets. So I think that's one really interesting area, is like using AI to start helping to determine why certain things are happening, why people might be at risk for particular conditions, and really enhance the level of discovery that we have right now. I think that another thing that's kind of trending is that people are realizing the limits of just using a pure data approach. That there needs to be involvement from clinicians and domain experts and all that to make sure that these kinds of things get adopted and are based on sound principles. So I think that healthcare will gradually be more accepting as as we kind of mature in our approaches to data science and bring in our clinicians, bring in domain experts, bring in healthcare marketers, bring in people that can inform while we're trying to cross that gap into using AI to figure out why things happen. It's going to take us to fill in those gaps and make sure that we're guiding these machines, we're asking them the right questions, we're assigning the right labels and doing the right things to better engage our patients.
All right, so there's a lot there. We could just keep going on and on. I want to wrap and give you an opportunity to talk about one last thing, because you guys talk a lot about in your videos. In my exploration of AI, it comes up over and over, and it's very important in the space of healthcare, and that is the bias that can be found, which is, it's not machine bias, it's human bias built into AI. So you want to speak about that for just a little bit before we go?
Yeah. And like the conversation that people might be seeing a lot is the question about whether or not AI is racist, or whether or not it embeds bias and then kind of systematizes it. And that's a question that the reason we put out Health AI University and racist, gender bias, sexism, all kinds of different things that could be embedded based on past processes. So there's what AI is reflecting, like in that method that we discussed, is it's looking at historical encounters and looking at historical transactions. In those transactions, what if there was a significantly higher proportion of white patients than black patients? And even further, what if Black patients were coded differently because of bias on particular clinicians' parts. Well, that gets reflected in the data and creates a scenario where, like, if I run an algorithm and I want to outreach, let's go back to the cardiology example. I want to reach out to the people that have those specific needs, then I would end up like, because of the way that the data was collected and generated, if I wasn't looking at it and asking those questions about bias, then I would end up underserving a significant portion of the population. People who need those communications wouldn't get them. They wouldn't know about services and intensely needed things for their care. So I gave a speech with Haley Sue recently on racism and AI, but the basic concept is that we want to equip leaders with like an understanding enough to like everybody on this call is going to be making decisions that involve AI software. AI is already predicting what you're going to say next. I mean, it's already here, but it's been talked about in such a way that's really convoluted, scary, hard to understand, and makes people afraid to ask the important questions, such as, hey, like, what's the process for testing for bias or sexism or other ways that AI could discriminate and cause problems. So the good news is that once you know, once you're starting to consider the possibility that your data might reflect racism or bias in overall business processes, then we as communicators and people in patient engagement, we can start thinking about, okay, well, let's adjust these thresholds. Let's adjust our approach so that we can make sure that we're reaching those larger portions of audiences. And I'll say this, like with algorithms that we work on, we started testing for this and researching this, and we tested a algorithm that was race blind, like didn't include any factors about race. We completely left race off as a feature or variable, whatever you want to call it. We tested that versus an approach that would adjust thresholds and adjust communication outreach based on whether or not a population identified was underserved. And by doing that, it expanded the outreach to the underserved population by 23%. So when, like, if you're a data scientist watching this, or if you're if you're like anybody involved in the process, like, what I would say about the bias question is it's time to start asking questions about about the algorithms that we're using, and taking the potential for bias into account and implementing controls to be able to make sure that we're getting our outreach to the people that need it.
Yeah, it's such important stuff, Chris. And it just reminds me a little bit of when marketing automation came along, and, you know, when you're talking to executives or folks that don't get it, and they're like, oh, marketing automation, so I just push a button and it all works, right? That's not how it works. And I think there's an assumption, a really fundamental wrong assumption that, well, AI takes the human out of it, so that takes the bias out of it. Well, you just laid out why that's not the case, because the data is coming from somewhere. And certainly there will be data that's not influenced by humans, but most of it is in some way. You know, how it's collected, how it's disseminated, how it's sorted, whatever it may be. So it's just really important, I think, to keep that in mind. You guys, again, do a good job of explaining that in your videos. All right. Well, again, we keep going and on and on. We've hit our mark on time, which is not a shock to me. Really appreciate you joining us, Chris.
Hey, appreciate the opportunity to be here, and the fact that you're willing to open it up to that conversation on bias and deeper issues that I feel just don't get talked about enough when it comes to this stuff.
Yeah, and we survived the live LinkedIn. So Chase is happy about, I won't be haranguing him about what's this and what's that. Maybe we'll try it again. Who knows? We are exploring moving to this platform. So if you're new, we usually do this on Zoom, and there's an invite and all that, but this may be a more organic way to just engage with people where they're at, when they're at. So, and again, we have to thank Chris for that, because that's where we got the idea. So thanks again, Chris.
Thank you. And until we get absorbed by the technological singularity, I'll see you next time.
Well, hopefully I see you before that happens. Chase, thank you for joining as always, sir.
Yeah, of course. Enjoyed the conversation.
If there's something you'd like us to cover, just put that in the comments section if you're still hearing us live. Otherwise, you can shoot us an email at nonormal@thinkrevivehealth.com. Remember to visit thinkrevivehealth.com/no-normal for a recording of this show and all past shows, or visit your local podcast resource center, wherever that may be. And until next week, good luck out there in the no normal. Thanks so much for joining.